Mute. Good. Now I'm on mute. Hello, everyone. Sefis, thank you for the introduction. My name is Lernik. I'm co-founder of Beegraphy and chief product officer here. So we started this Computational Design Awards, launched it together with Uni XYZ. Abhishek, the founder of Uni, is here. And there are a few folks from coding here. Let me share presentation that I have. Okay. Take some time to load. Let me know when you can see it.
Yeah, it's visible.
Okay, cool.
It's facilitated now.
Full screen. Loading. Okay. So I'll do a quick intro of ourselves, do an overview of Beegraphy, share some info about the competition. Probably I better, on the competition part, I give the floor to Abhishek, who's the founder of the competition platform, and then we'll give the floor back to coding to do the workshop. Oh, the certificates? Yeah, put it for myself, not to forget, but everyone who participates in the workshop will get the certificates that they accomplished this computational design course. These, this is a picture of us founders of Beegraphy. A couple of years ago when we were younger and I had a bit more here, a bit more hair. Like this guy on the right is me. Um, so what Beegraphy is, it is a computational design or parametric design platform, which is web-based, completely on the cloud with collaborative functionality enabled. Our focus is on democratizing computational design. We see a lot of power in computational design, but there is a limitation. It's not accessible to everyone. It's difficult to understand, but it's also there is no good free software for computational design. So what we are trying to achieve is we are trying to give free access to computational design tools so that anyone who is willing to learn can do so, regardless in whatever part of the world. You just needs access to internet and some will that we can't control. On the other side is the product of computational design, a parametric model. It's very difficult to share the model retaining its parametric functionality at the moment. So at Beegraphy, we're trying to solve that problem as well, so that computational designers don't keep the product to themselves only. Uh, Simply put, we're building something like Google Docs or Figma or Miro, if you like, or Canva, but for computational design sphere. So our main differentiation from what exists on the market, that it's easy to share. You don't need to send files, just send the link. You can collaborate with multiple people, with your teams in real time. You don't have to show the script, your intellectual property, when you share the parametric model. And it's online, so it's easy to integrate outside of Beegraphy, like create your portfolio websites or integrate to your, I don't know, e-commerce, for example, or your company website. Cephis will cover the interface of Beegraphy and during the workshop. Not stopping here. Just a few more words. The Beegraphy has become global. We have users all over the world. Well, not all over, but in 114 countries. So like half of the globe and in all of the biggest countries. And in some countries, organically, Beegraphy has become used or integrated into the education process. Those countries we highlighted in yellow on this map. And I could see that the founder of Go Math Academy Miss June joined this workshop. June, I'm really happy to see you. You're also here. By the way, probably we'll cover some use cases. So use cases are different. Some use Beegraphy to teach architecture, like Nantes University in France, or CEPT. I can see lots of people are from India, so you can recognize CEPT. They teach digital art in Denison University in the United States using Beegraphy. And I mentioned South Korean case. They teach mathematics for high school students in South Korea using Beegraphy, so we're really proud of it. This is some pictures from South Korea. This is from a class in India. And this is from a small island called Mauritius. I don't know if everyone can tell where it is, but the island is right there. You can barely see it on this map. And I'll take just the word to say that we commit that Beegraphy will always remain free for education. Now, let me give the floor to Abhishek.
Thanks,
He-
Ranik.
Yep.
So I'll just quickly share the screen and won't take much time. Is my screen visible to everyone? Yeah.
Yes.
Hello, everyone. I'm Abhishek, and I'm running uni.xyz, which is a competition organizing platform. We have partnered with Beegraphy to bring you all this design award on computational design. So we are running this design award across 10 categories, which is furniture, home furnishing, fashion and jewelry design, lighting design, education, urban furniture and installation, art and collectible. In architecture, we have building facade, then engineering and DIY kits, then dynamic design, which is again could be in architecture, could be in product design, and there is an open category which is there. We call it miscellaneous. So these all categories and their challenge requirements are given on the uni.xyz website. So you can visit over there and explore all these categories, the different challenges that are posed over there. And the first deadline for the art and collectible category starts from August 5th, and it will go on till January next year. So don't forget to check out the different categories as well. Spread it across among your peers, team member, your junior, senior, whoever are interested in computational design, in learning, participating, or trying hands-on experience on this. So this award is open for all. There is no entry fee. It was launched on 13th of June and across 10 categories with 7,000 USD as the prize money. We are inviting all professional and students. So there are separate prize money for professional, students, runner-up, and there are best in category award for each of these categories. And don't forget, like it will be published across many digital publisher like Arc Daily, Design Boom. So there is a lot of marketing that is going to happen. So if you win this award, a lot of fame you are going to get. Not only you are going to learn from Beegraphy and this workshop, but there is a lot more in the box to grow and I mean spread your fame. So this is the jury panel, and it's not limited. We are inviting more and more experts. So creators like Gedi Minas and founder of Parametric Camp from Harvard University, founder of Parametric Architecture, Hamid, and Safiz himself is there. So a lot of famous personalities are there who will be evaluating these entries. The first stage is all on Beegraphy, where you will have to create your design and publish on the marketplace, which today Safiz will be showcasing. Safiz and Divya will be showcasing. And there will be the second stage once the shortlisted entries from Beegraphy. We will shortlist around 10 entries from each of the categories on Beegraphy. They will be invited for the second stage, where you can submit your entry on Uni with all the details, with the graphic, with the concepts behind your design and use cases. You can also showcase the 3D model by embedding the, the 3D viewer of the Beegraphy directly in Uni. So I'll be showcasing all those things today and in the coming workshops. And there will be 4 workshops overall. I believe CODIN team will walk you through this whole thing, this whole workshop. So I'll be handing over the floor to Safiz and Divya from the CODIN team. No. Thank you.
All right, thanks Abhishek, thanks Learnic for giving us a much needed insight into Beegraphy and also the competition. Like before we head into the workshop, me and Divya, we would like to introduce ourselves, a little bit about CODIN and why it makes sense and why it was a no-brainer for us to be part of this journey with Beegraphy. So let me quickly share the screen. Yeah, is it visible?
Yep.
Yeah.
All right, quick. So we'll quickly go through what our vision is, give an introduction of who the coding team is, and how this collaboration is also quite important for us and what we believe, why it's important for the parametric community in general. So our vision is to push for design innovation and make it accessible to all. We are on a similar mission of like how Lernick mentioned of democratizing education, and that's how we aligned quite well from the initial stages. We look at the education state and why this particular change is needed, and that's also why me and Divya and a few others who are part of CODIN started on this mission of establishing a transformative education platform called CODIN Edu. It's one of the vertical of a bigger ecosystem of CODIN, where we push for education and trying to make it innovative and accessible both online and offline. We are providing courses at universities, providing online workshops, like the current workshop that we're all part of. And we're quite excited about the whole journey that we are in, and I'm sure it'll be exciting for each of you to have an insight into one of these. Our principles are primarily to push for exploration, bring exploration into education, innovation, make innovation a key part of our vision, and also work towards constant upskilling. Like I mentioned, we do online workshops, design studios at different universities, and summer winter school programs. We have a few courses ongoing, and Beegraphy course is our latest course that we'll be kind of pushing forward for the upcoming months. These are some of the other courses that we've been developing. We have tutors coming in from across the globe. And these are the minds behind our vision. And for this particular workshop, it'll be the 3 of us, main team of CODIN Edu, who will be taking care of the workshop. For today's workshop, it'll be me and Divya joining the workshop sessions, taking over 3 modules. And Ayush will be joining us later on. So yeah, our mission is to inspire design innovation, exploration, and upskilling. These are some of the student works that we've been quite fortunate to witness, and some of the images from the courses. So yeah, so this is like a quick intro about what we do as CODIN when it comes to the education aspect of it. Now, we thought this was very important so that you understand who you'll be joining or traveling with on this educational journey of a couple of workshops. So without spending much time on that, we'll start the workshop. Yeah. One more thing that I might have missed out. Yes. So as Abhishek mentioned earlier about the different breakup of the categories of the works of the competition, we are also organizing these workshops to align with these. So today we have 3 modules, 2 of them taking care of introduction to parametric design theory and mostly the basics of parametric design on Beegraphy, so that you're all getting used to the foundations of it. And then we will be looking into art and collectibles category. So we'll take an example and then develop the whole process, implement the whole process, and that'll be a good example or a case study for anyone taking part in that particular category. And subsequent workshops will be happening every month, and each of the module will cater to that particular category, which happens before the deadline. So I'm sure anyone who's taking part in any of them could track these schedule and then take part. And I would suggest everyone to take part in all of them. It's good information understanding. You could easily develop your computational thinking on how to take from a concept to a fully developed form, and which could also then be a submission for your as a design proposal. Yes. So let's get started with the workshop. So I'll be taking care of the first module, which is parametric design theory and Beegraphy basics, part 1. Before we get into this, the structure for this module would be we'll look into the introduction of parametric design, give overview of Beegraphy. We'll see how to start a model, manage a model, look at the interface and the basic functionalities of the tool. We'll also look into nodes, parameters, and constraints. So these would be a necessary foundation for anyone, not only heading into Beegraphy, but also as an understanding, a better understanding for parametric design. So we can start with the introduction to parametric design. So what is parametric design? It's not something that's very new. A lot of people have been working on this, developing concepts, theories, tools on this particular topic. And to put it in like easier terms, it's a process where you have some parameters or algorithms that define a type of shapes or forms, which then enables you to make a flexible and an adaptable design solution. Right? So 3 key elements. You have parameters and algorithms that define shapes and forms that provides a process which is more flexible and adaptable as a solution. Now, what we'll need to do is to compare with what traditional design process is to have a better understanding of the advantages and disadvantages of parametric design. Now, if you worked on tools like 3D modeling tools like SketchUp, Rhino, or any other modeling process, you'll understand that it's quite static and linear process. It's more of a sculpting. You make manual adjustments on a fixed geometry, and therefore the flexibility is quite limited. But when it comes to parametric design, as you learn more, you'll understand it's more of a iterative and dynamic process. You constantly play with the inputs, and then you see what the output looks like. You again play with the inputs. So it's a back and forth. And then once you understand some of the variables, you can then convert it into constraints so that you don't want to change it. So it's more of a back and forth. And there is a lot of variability to the geometry. So you can have maybe tens or hundreds of options within a span of a few minutes and see which one works best for you. And therefore that enhances the flexibility. So put comparison in a table. This is how it comes like. And it's not all advantages. Okay, so disadvantages are also there, which has been a barrier of entry to parametric design. A lot of tools have a much steeper learning curve, and that's been a challenge. Uh, we've been trying to solve it through making the courses simpler, but the tools are not super user intuitive, and that's been a challenge to overcome this steeper learning curve. And also the initial setup time is longer as compared to traditional. So if you're making a model and you have like few minutes, you would probably go with the traditional one. But if you want, or if you expect iterations to come later on, then of course, then parametric design becomes more and more, uh, how to say, obvious. As I mentioned, it's not new. There has been a lot of work that's been done in practice when it comes to lighting design. Furniture applications are there in all different design fields. It's there in fashion design. You can see a big pavilion designs, facade designs. They've all used parametric design processes to develop these forms, dynamic design, also wall art. And you are now able to see some of these parallels and why there are different categories, because computational design or design tool is not limited when it comes to its applications. So that's why we have a lot of categories as well, so that anyone from any field can try out this process and then give a go at it. We have also been trying as part of CODIN Parametric to develop some forms, some interesting forms, complex geometries that if you try to do it through a traditional method, you would find it tricky and challenging. And if you have to make 4 or 5 iterations of it, you can imagine how long that would take. We have been developing those forms with Beegraphy, and the results are very impressive. So as you start trying, you could use this as benchmarks and try to make something way cooler than these. So this just gives an idea of how much you can push the limits, right? You can push even further. Currently, the tools that are in the market that are available, I would say you have Grasshopper on the Rhino ecosystem, and then you have Dynamo Private, and we have Beegraphy. The difference is the other two are more local. You have to install it in your computers, but Beegraphy is more web-based, as Learning had earlier mentioned. And you can see the shift in most of the tools and softwares, organizational tools. It's slowly heading towards cloud-based, most of the tools, because it's more about convenience. You want to access it uh, at your convenience wherever you are. It doesn't matter if you switch your computers, if you're on your work laptop, if you're on your home PC, wherever you are, you don't have to constantly carry files. So that brings a lot of convenience. Also devices, right? You want to work on different devices. So these have led to this shift, and therefore, me personally, I think Beegraphy could be the tool for the future when it comes to parametric designers. So yeah, so let's all hop on to this invitation from Beegraphy, and let's all join the journey and start working on it. So let's look into Beegraphy a bit more. So what is Beegraphy? Lernick mentioned earlier that it's a cloud-based platform, computational design tool for the cloud for 3D modeling. Another interesting thing is that it's developing as an ecosystem that is built to meet the evolving needs of modern computational design teams. So as I go deeper into some of the functionalities of of Beegraphy, you'll understand there are possibilities of collaborative tools, teams, the requirement of team as it develops. I think those functionalities have been integrated quite well, and these are things that make Beegraphy noted down some of the strengths among many, and these are one intuitive interface. I mentioned earlier that when it comes to parametric design tools, the steep learning curve has been due to their interface becoming less intuitive and becoming more challenging for them. So I think Beegraphy has managed to make it much intuitive, collaborative, and compatibility. So these three words are key strengths that everyone has to keep in mind among the other. But when it comes to intuitive, you have all these functionalities within one common interface. You have the 3D viewer embedded. You have icons, tools, all accessible. When it comes to collaborative, all these people working in the same file, you know, these kind of things, people who are currently working can clearly understand how you have to share the file with different people and get comments from each, coordinate a lot. While on Beegraphy, you can just everyone can access the files based on different access, uh, and each of them can give comments. You can also provide just the viewer mode to the client so they can check the output and the progress of the model. So it's collaboratively super strong. I don't think there's any other tool in computers today who would be doing this anytime soon. Compatibility is also very exciting. You can use this on your phone, PC, laptop, and all devices. And I'll want to push learning to see if we can do a VR version in the future, where you're developing on parametric tools, in VR. That'll be pretty cool.
We will do that. I think early next year we'll have AR VR.
That'll be crazy. Cool. So those three things, but it does come with a few pressure points. But the whole Beegraphy team is there to support us. So currently, it's all being done on the cloud. So very heavy models. You might start to find some challenges, but we can figure out ways to make it or keep the model lighter. Adding plugins, just started slowly building. Like, I think that's something that we'll be introducing soon, right? Learning, like adding
Yeah. The
new.
plugins manager, Beegraphy plugin manager, as we called it, BGPM. We are working on it. It
Yeah.
will be available, I think, hopefully next month, or like at least the first version. Well, the something is already available now, but it's like very limited in functionality. We will constantly work on it. I think in a few months it will be already featuring plugins for everyone. The bugs part, it's something inevitable. Like every time we add a feature, it may come with a bug, but we are trying to squash them very early. And I rely on the community to report everyone, each one of you. Let us know. We are available on Discord. You can find me on LinkedIn. You can email us, uh, me directly or anyone from the team, and let us know that something is wrong. We will be really happy to address the issue. Well, in the larger models, it's something more complex, but we are improving. I think we improved the performance about 100x in the last 2 years, but there is
Amazing.
way to go.
Yes, and yeah. Beegraphy currently has two pillars. One is the editor and the market. So the editor is where all the how do you say, all the work that happens, your modeling, algorithms, all the yeah work. And then you have the marketplace where you upload all your models, where you access the models. It potentially creating a like a creator economy where you can also list your model and also sell it probably, which is quite cool. And another advantage is that Pgraphy provides you with different parameters to control the models. So you can, so it's not a fixed model that you find in this marketplace. You can customize the model based on your requirement and then download it. So it makes that the market is quite dynamic, which is also a very unique feature out there. This is also cool, the API integration. So if any of you want to integrate your models or forms into your website, that's also possible. And it makes for a wonderful portfolio with your 3D modeling tools and everything, showing off your skills, allowing your whoever is viewing it, the user to play with it and see and gain a better insight into your understanding of parametric design. So yeah, when you open Beegraphy, so this is what you see. You'll see an editor, marketplace, and all the other tools. What you need to do first is log in. For most of you who are first-time users, you will be signing up, and once that is done, we can get going. So what I'll do is I'll head to Beegraphy, and then I'll go through the process so you'll all follow it. Yeah. We go to beegraphy.com. Like I mentioned, you see the editor, you have the market, and then I've already logged in. So just fill in your info, and then you're good to go. All the required information here. You have support, you have the guide, all the editor, any questions you can ask the team. Head to the editor first. So this is what you see in the editor. Once you sign up, yep, you're back. So this is the workspace home. This is what you see when you sign up and go into the editor. You have the profile on top. This is where you can add your images, add more information. You have your models. All the models that you work on will be here. Some of the assets, some fonts that you can upload, images that you can upload, which later you can utilize in your scripts, can be uploaded here. Another key feature that I mentioned earlier is creating of team. So you can create a team and give access to each of your team members and decide who's working on which project, etc. And finally, creating a new model. So this is what we'll do. So let's head back to Beegraphy once again. So yeah, we have, you can access the market from here. You can develop your portfolio, your account details, you can change your password, all that, image, add your image, set up your profile. You can add favorites for quick access to your models. You can check the models that has been shared with you by other users. And if you have already published a few on the market, you can access from there. Now, if you want to create a team, give a team name, and then you can give yep. And then when you add projects, you can have it there. Now let's start a new project and get into the editor interface where all the magic happens. So let's create a new model. workshop 1A. Delete them. Yes. So this is the interface that you'll get once you sign in to Beegraphy. You'll have most of your tools here. This is your 3D viewer. Now you don't have to go elsewhere. All whatever you develop will be seen here. You can set up different view styles, view modes, zoom in and out, grid. This is where you for script, you add your components and develop script. People who are familiar with other parametric tools, I think they'll be easier. It'll be way easier for them to grasp. Quite intuitive. This is where you add the components, and this is where you see the model getting developed slowly. Here you can see how many people are working on the file. So currently it's just one. If you have multiple people part of your team at the same time, they'll show up here. You can have some comments, and you have a few other user zone related functionalities. Heading back to Beegraphy again, we can just go through the same things in more detail. Click this, you'll go back to your home that we saw earlier, just to view all the models. You have some Q core components. If you want to export, you can come here and add some material. Most of the tools that is available on Beegraphy, you would be able to find it here. Surface, vector, transform, curves, all these tools are here. If you want some math operations, those are available, the list. So this is your main friend. Try creating something simple so that we can see something on the viewport. Okay, so as soon as you create, you have it in your 3D viewer. Zoom in. And also make it full screen. Quite cool if you want to deep look at the model. And also change views from perspective, top view, front, right. Easy. And if you have, then add ground plane. That's also quite possible, easy to use. Now, when it comes to the user zone, we have the number of users here. We have some comment section here. So if you have your teams involved and you have multiple comments that's been added, you can view them from here. And then you have these two different modes. We'll get into these later on, where you can demo the output of how it looks like. So this is about the basic interface of the key components on your landing editor page. Now let's look into nodes, parameters, and constraints. So you'll need to understand this for having a better computational thinking. Yeah. Now, when you double click, you saw a lot of comments, a lot of components or nodes and we opened up a box and you found this. Right now we need to know what this actually means, what each of these icons mean. So let's go into these. So nodes. So these, the one that we opened up, most of it are called nodes. So fundamental unit of parametric design system that performs a specific function or operation. Like that's what nodes are. And these represent actions, processes, any component, any function that you want to introduce. Those are called nodes. Now, every node has different components to it. You have the name, icon. These are the inputs. These are specific inputs. You have input values and you have the output. So these are what each node component you'll see. These are elements. Now you'll find these 4 different node states. If you have a node which is normal, this is how it looks like. If you select the node, you'll have these yellow outlines around it. If you have hidden a particular node, you'll find these diagonal hatches. And if there is any error with what you've done or the type of node that you have introduced, they'll show in red. Whenever you work on these scripts, it's always about a matter of input and output. Right? So this is the output coming from one of the node to another node to its input. So this is how you keep working and building up the script and your logic. Now, when you've done it correctly, this is how will come. And if you think about how the data is flowing, so you're building a circle, and the circle requires an input, which is a point and radius. And what you've provided, you've constructed a point here, and you've given the output of the point and provided to the input of the circle. Therefore, it's correct. But when you try to do something which does not make sense, say in the case of extruding a curve, it is asking for a curve, but what you're providing is a surface, right? So then it shows error and thus red. You can add multiple inputs as well into, so if you have a circle and you want 3 circles of different radius, this is how you can do. You can create 3 different values and then you can input all of them into one node. And the same thing goes for output. So if you have a curve and you want different things to happen to each of those curves, you can have multiple outputs connected to the node as well. And if you've done everything correctly, you'll start seeing things on the 3D viewer. Cool. Now we've discussed about the nodes, and most of the things fall under 2 categories when you're developing a parametric model. One are all the parameters, and then you have constraints. So parameters are the main foundations of parametric design. So this is what gives it the strength, the flexibility to manipulate the models and make it adaptable. Constraints are what make sure that the structure doesn't violate or your script doesn't violate certain design principles. For example, if you have a setback which is fixed, it's better you provide it as a constraint, and therefore you could approach it like this. In Beegraphy, you have something called a range input. So what range input is, it provides numbers between a range. And this makes it flexible so you can move around within that range, right? There is another component called number constant, which provides a constant number, which you can edit it by changing the number, but it doesn't change as a variable. So in the case of any information or data that you want to keep it variable for a user or yourself, you provide a range input, but any data that you want to be fixed, you can keep it as a number constant, right? For example, if you're doing something where You have speed of light or acceleration due to gravity or something that you want to be constant, pi, for example. You add it as a number constant. An easy comparison would be if you are creating a rectangle, you can create it in both ways. It would still work. One, you can create it as a range input, give a number between 1 to 100, and you can keep it both width and length as a range input, or you can make both constant. Right? These are ways you can develop a script. You could also do it hand in hand. So if you have width that wants to be more flexible and length to be a constraint, that's also possible. So if you have a barrier on one side, you keep that side as a fixed and then you move around. So it's more about how you develop based on the requirements. Now let's head to the Beegraphy platform and develop the same. Delete this one. Okay. There you see. So now you can see a rectangle. Now Beegraphy has provided width is 20 and length is 10 by default. Now what we need is to position the rectangle first. So we need a point, construct a point, provide it to the rectangle.
Cephas, maybe
Yes.
change the viewports to the shaded mode.
Okay.
Yeah, and maybe
Yeah.
turn on the grid. Yeah, look better. Thanks.
All right. Cool. So there were a few things that we discussed earlier. Those were parameters, variables, or constraints. Now let's add a range input as one of the variables, right? Now every point that you want to define on a 3D space requires a value on the x-axis, y-axis, and z-axis, and this is what will create. Now, if you hit the drop down, you can give the range. Let's say minimum 0, maximum 10. You can hit Control C, Control V, paste this 3 times, and then make the connections. So right now, the location of the point is at the origin because you've given 0, 0, 0. And the rectangle is starting from that corner. Now, if you keep changing the location of those points, the rectangle also starts to change. Cool. And that's what you do with the rectangle as well. Now you have width and length. We'll try to keep a constraint for width. And constant number. Okay. And then we can have length as a parameter. And therefore you use range input. I'm keeping 0 to 100 so that you can see the variations much more. So that's how you do it. So you have this as a constant, this you don't really want to move. So you can have that as constant. You can also have that width as well as the range input, and you can constantly move around. So this is in the case of a rectangle. You can also see the same concept work again if it comes to like a box where you have three. So now you're creating 3D geometry out of it. So you have width, length, and height. If you have a form whose height needs to be restricted, you keep that as a constraint and then play around with the width and length. So this was a quick demo into, let's say, nodes, parameters, and constraints. And yes, thank you for listening. So this is just the first module, like an introduction to parametric design and a very intro basics part one to Beegraphy. We'll dive into the topic deeper as we go ahead in our workshop schedule. So yeah, so I think if you guys have any questions, please write it in the chat about what we've just seen so far. Sure, we'll be looking into it more in the upcoming sessions. Yeah, and then yeah, we can break for 10 minutes and then come back again. Yeah, learning. What do you guys think? Sounds good.
That sounds good. Probably a 10-minute break will help. So the time is different for everyone, like 10 past whatever hour you have, you all have. Cephas, just one quick question. I guess you know that we have what do you call it, shortcuts, like for the number
Yeah,
on the range input. You
yeah,
intend
yeah,
to avoid it. Okay,
yeah.
just to make sure.
Okay, all right. So I was just trying to get them through the basics because a lot of people contacted us who would not only new to the tool but new to the whole parametric design concept itself. So that's
Mhm.
why I was thinking like, because we have resources and we'll be taking all of them through this slowly and slowly.
Got
Yeah.
it. Okay. Then let's take a break. Unless anybody has any question.
Yeah, perhaps we can utilize this 10-minute session for Q&A. So any questions you have, you might place it in the chat box and we will answer. So one question is, why do the inputs have different color, blue, green, red?
Learn it. Do you want to take this one? Why do
Uh,
the inputs have blue, green, red color?
yeah, if you do more of this, you will find it intuitive. But basically, there are different data types or geometry types that you're going to be working with. So to make it easier for the users, we differentiated it by color. So Cephas in the beginning showed a situation when you get an error, like you're outputting a surface and you're using a surface as an input for the other node, but that node wants a curve. So there will be this conflict. Those colors will help you figure out that, okay, they are different colors, so I shouldn't be connecting ports of different colors. Although there are situations when one port accepts different data types. For example, apply material nodes you can give it different types of geometries, like you can give it a curve and then apply material to the curve, or you can give it a surface or a solid. I can see a new question. Or
Yeah, the
actually,
other one is in Grasshopper, we have BRIP and deconstruct BRIP, like boundary representation. How can we do something like that in Beegraphy? So as far as I know, I think there is a node called deconstruct solid for that. Am I
Yes.
right, Lanik?
yes, there is.
Yeah.
We do have deconstruct. In fact, the geometries in Beegraphy right now are BREPs. So yeah, everything is a BREP, I think.
So for deconstruct BRIP, you can use deconstruct solid.
Exactly.
Okay, the next question I wanted to ask. Yeah, so the recorded session will be available, will be uploaded on YouTube and Vimeo, and will also be available on the Beegraphy Design Award page. So this question has been answered on top.
Mm-hmm. Okay.
All the recording will be available.
Yes. So there will be a link on the Uni XYZ page
We will
dedicated.
be embedding the video over there. So one can directly go to the Learning Resources tab and watch these recorded sessions.
Mhm. Cool. By the way, my background disappeared.
Next question is, can we import geometries from other software to the script and modify them?
You skipped. You skipped one more question. uh,
Yeah, I'll come back to that.
okay. At this point, like at this particular moment, it is not possible. We will be developing that functionality. So, in fact, we already can do that. It's just that there are some challenges. Like if the user start importing bigger geometries, it's gonna crash. So we're trying to find a way how to enable the functionality, but also tell the users or make it intuitive for the users to understand what kind of geometries they should be importing and what is too big for the web. I don't know if I answered the question.
Yeah, so I mean, what Learning is saying is probably in the future updates, they will have this functionality to import model from geometries from other software. So it's more like a compatibility issue, right? I think Learning.
Well, depending on the software, like we definitely can at this moment enable B step import, which is a BREP, also STL and OBJ.
Mhm.
The others we need to fix yet. Like by the way, there is also a possibility to import SVG.
Okay, so there is another question which we missed from Lynn. Will there be any Python or C component available? Or is it
Uh,
available right now?
it is not available right now. There is Beegraphy plugin manager that was mentioned during the call in the beginning. It's the plugin manager, something like in Grasshopper. But if you are talking about the scripting node, I don't know when we're going to add that. There are some limitations that we have because it's running in the web browser and there are security issues. So if you add some script in that node and then share the link, like publish it on the marketplace, and users start opening it, there's a risk that we can't control what's in there, and then others can open the script if there's anything malicious, like a phishing thing, virus. There will be a lot of problems that we're trying to avoid. So we will need to find a way how to enable scripting without compromising the security.
Cool. So I think all the questions have been answered so far.
We have 3-4 more minutes for the break. Yes, Apis. I realized at one point that you were thirsty, but you kept talking. Why is Divya so serious? Glad we sorted this issue with the chat box. If there is anyone who wants to put a note in the chat box but can't, there is a raise hand button, which you
Yeah,
can.
we will make you a contributor.
Yeah, just click on that. Okay. Scott. We should. How do we do this? Okay. Yeah, Scott, now you're a contributor. You can text in the chat box. Thanks for raising the hand. Good question about Speckle. We get that question very often lately. So that means we definitely need to do that. We already looked into that. In fact, we had a call with Speckle, I think last year, but then we thought probably it's not that critical because there were more important things, more pressing issues back then. But probably at this point, we can add it to the task list. And I think it's something that we can develop quickly. Maybe in August, we can have it. By the way, Scott, since you asked about the speckle, maybe you could elaborate a bit on how you want to use it with speckle. I'm just really curious. BIM integration, another good question. Yes, thanks for the question. We do want to, but I don't know. Maybe Speckle will help to, like, integration with Speckle will partially solve that problem. And like full BIM, I don't know, maybe later this year or early next year. Unless we get lots of requests about BIM and then we understand that, okay, it's more important, we need to prioritize it. Our CEO is also on this call, so he's probably also taking a note that we need to work on BIM.
Someone has asked, do you have an example of a complex configuration in Beegraphy? And what is so special about it that can only be done in, I think he wants to say Beegraphy, but he wrote photography over there. So any complex example of, a modeling in Beegraphy?
Okay.
I think there are a lot of examples on the market, on the marketplace, Beegraphy marketplace. You'll find a lot of models.
Any
And
specific one which you would like to point to?
like if the question is targeting towards comparing it with other complex tools, like what it's been done on Grasshopper, I think it's still getting there in terms of complexity, because the heavier the model gets, there are different ways to go around it currently on Super, but the explorations that we did on CODIN Parametric were, I think, quite detailed. But then there are, yeah, I saw some interesting ones on the marketplace.
I shared the link of the marketplace, so you are free to explore, go there and check out some of the model and the configurator as well. How you can achieve different design configurations using these parametric tools.
I think Bhagarat wants to know the best one done so far, so that for the competition, he keeps that as a benchmark.
Yeah, I mean, that is something which you will have to break. The benchmark is set up there in the marketplace, but the more complex model which you'll make, your design is going to be better.
Yeah. Bhagarat's from the Creators Club at CODIN Parametric. Hi, Bhagarat.
In fact, about the complexity, like it's changing daily. So what's possible now or what's limiting now will not be limiting a week later, and closer to the end of the competition, probably it will be, well, not probably, most definitely, it will be more powerful and be able to handle more complex geometries.
That's also the advantage of the competition, right? Because you see all these ideas come together, everyone pushing the limits of the software.
Yeah.
So I think that'll be pretty exciting.
I think there's just one question that we skipped, but then let's move on to the workshop. Let me take that one about the API. What can be done with the API except for viewing as a portfolio? Yeah, well, portfolio website is one use case, but we will, it's like work in progress. We will be developing it further so that you can integrate it into other applications. For example, most popular use case probably will be e-commerce. Like if you're manufacturing or selling custom products, you can easily create a 3D visual product configurator that will generate dynamic pricing based on the parameters changed. And then the person will not be clicking the button to download, but will be clicking a button to place an order. And then the seller will be receiving the fabrication files and the specification for the order. But if you have other applications in mind for the API, share. We would be happy to give it a thought. Oh, someone asked about the
Hard
business.
question.
I don't know. Sure. Okay, the last one before we continue. So the business model. There's marketplace. You can publish them as free or showcase only, meaning that other users will not be able to download, just play with parameters to see the variations. But you can publish it as a paid model, and Beegraphy charges a 15% commission from all of the sales on the marketplace, and the sales will be like sale for each download or selling unlimited access to downloads. And also we plan to add functionality such as selling the script, the algorithm. So anyone who buys the script gets the file into his workspace. Plus the API is something that we want to monetize on. So like when it's going to be used in e-commerce, that will not be a paid feature, but we will make sure that it's the most affordable option. Like there are options like Shape Diver and Pack Hunt available on the market. They are costly for small businesses. We'll make sure that it's definitely not breaking the bank. So anyone who wants to integrate it will be able to integrate and make money, not lose money. Yeah, let's move on.
Okay. Yes. See the screen? Okay, yes. Cool. Now to Beegraphy Basics Part 2. So this part of the workshop will keep it more hands-on. Previous one we went through the theory and some of the introductory points. So this one I just want to try out some tools so that everyone gets introduced to towards there on the toolkit. What we'll try to cover are exploring some simple geometries, transformations, some Boolean handlings, material, looking into applying material and exporting, and then some troubleshooting of common issues that we might come across while modeling. And then we can head directly into the browser. So earlier we looked at all these interface elements. We have the tool tab here. You have some math functions here. So we'll go step by step. We'll try out a few, and then we'll see how we develop small scripts in containers, and then attach it to develop like bigger components. Try to understand something that's a bit more complex. Break down the thinking in simple terms. This is not like intermediate level. It's still basic, so that everyone gets to understand. And of course, we'll increase the difficulty as we move forward. And we don't have any direct some target form that we're trying to achieve. It's more of the exploration at this module as well. And then from the third module, we would be showing something related to art and collectible, where we'll have an end goal and then we'll develop it into it. So yeah, so first thing would be to understand how some of the math operations work. Easy way to think is if we drag the addition one, what you have is two inputs. We can give two numbers, say 25. Output of this goes input. And then you have another one. If you hold Alt and then if you hold the node and hit Alt, you can duplicate it. So that's an easier way to duplicate. You can add this, and then you get the number. So there is a command called panel. If you connect it, it provides you the value. We can play with the numbers. So this is like a quick intro to input output and giving the initial parameters. Now let's come to something a bit more challenging. It's not challenging, it's simple for most users, people who have been used to parametric tools. Simple, but these things will come up later on. Second are vectors. So we've already constructed a point earlier. Point has three inputs, x vector, y, and z. We gave those points three values. You could also get vectors for particular directions. Like for example, you can get a component for a vector in x direction. And why this becomes useful or handy is because if you want to do some transfer, if you want to move an object, you would also need to give an input of which direction that it needs to move, and therefore the input becomes vector. So this is, say, vector in x direction. You have a lot of vector nodes here. You could also deconstruct a point to extract values out of that particular point. It just gives you understanding of how the data flows. So if we give 20, and then let's say we give like 15 on this. You can see how the data is flowing, and it comes back. You see all the lists in the same order of input coming as an output. So we've looked at points. Let's create a couple of points, and then start thinking from point to lines to curves to surfaces to solids, how we can develop it as a step-by-step process. This will probably assist you with the way of thinking of how things are broken down and how they combine to become something bigger. And in between, you'll have different steps that will help you develop the model further. You could either go directly from a solid box, or you can create a point, a rectangle, create a surface, and then make it into a solid. So these are different ways that you get more control of the foam. Double click on the canvas. Point. What we'll try to do is to create a line. If you go to primitive curves toolkit, you'll have a lot of ways to create curves. So the first thing, easy way, is to create a line. Now you have 2 points, connect both of them. Another cool thing that you can do to add values is you could create here directly and then add the numbers. Just giving some random numbers for now. And you can see how the model changes. And that's the line. So you can click on the line, and then you can go here and then zoom into the model. You can see how the line is performed. There are more tools that you can find on creating curves. You can create an arc using 3 points. So in this case, we already have 2. Let's just create more. Interpolate is also another interesting tool that allows you to create a curve through any number of points. Hermic, you just
Yep.
notice that when you drag with Alt, it's creating
Yeah,
many
I noticed
multiple layers.
it's a Windows issue.
So in this case, we're trying to interpolate with 3 points. So let's create this. So another point, let's say 16, 5, then let's say 2. And so we have 3 points. And then we can bring those points here, join it. And earlier I had shown we can add multiple outputs to one input point. So for that, we can hold shift, do it. Yes, because if you don't hold shift, this is what happens. If you connect another point, it just cancels out the earlier. So hold shift, and then you can connect all of these. You can hold control and then cancel out a particular connection. Yeah. So you see, now this creates an interesting curve configuration. Now these are things that you would probably use while modeling. You would want your geometry or the form in slightly unique manner. Similar tools. I think these components, most of them are similar commands to your other parametric tools, and therefore their adaptability is much easier. There is one tool that is unique to Beegraphy. It is the curve editor. So now we've seen some of the ways to make lines and curves. Now, if you want to create or customize curves even further, so you can use the curve editor. The interesting bit is what you see here is what you see on this particular window. Now you can change the curve, adjust it the way like, and then it adapts. You can also add more nodes to it. So I think this is a pretty interesting feature that you can use to create some geometries. You also have controls over the location of each of those points, control points that you have for the curve, and you can move it manually, or along with that, you can also control the width and height of the curve altogether. You can also increase the decrease, make it polyline, like a nerd's curve. Then use that as an input for your other functionalities. So these are how you can do curves. And it's you're just doing the initial bit, so everyone feel free to explore as much as possible. You have way more tools. You can have arcs. I'll go with circles next. We can try out circles. So in circles, what you need is an origin, which is a point. We could extract one of the points from here and then create a circle here. Another thing to just tidy up the script and your 3D space, you can hide. If you click on these 3 buttons, the set options that I was talking earlier, you can hide them. And now you see it changed status. So let's zoom in on the circle. Now radius is 10. You could either type the radius as a constant, or you could change it as a variable later on. So that's mostly about circles. You have surfaces. Now we discussed how we could move from points. So now points created curves or circles. And then now we'll look into how we can create surfaces out of these curves. So if you go to the surface tab, you have curve to surface. Just has an input, it just converts the curve that you've created. I'm not going for any specific form, it's just organic. I'm just trying to see how things change when you're bringing in different components. For a lot of the new users, this might be something that's helpful. Have more tools like you could create a pipe surface. Let's try that. Now I'm hiding the flat surface here. We have a base curve, which is this. And then now we add a pipe. I see the pipe has two inputs. One is the curve itself. So we divide it, and then the radius. So in this case, it's 10. We could create a range output for this and try to use it as a variable to play with. So we can have it for subject 1, 2, 3. Yeah, so complicated your curve is, you can always bring it in and then see what that does. Look at more functions. You could create rectangular surfaces as well. We did that initially. What you need to give is an origin point, and then you have your width and length, and that creates a surface. I addressed it then. Yes. That's how you create surfaces easily out of some curves. You could also use some additional tools, additional transformation techniques like extrusions, extruding a curve into solids. So that's also something that we could look into. So now we have this curve. We have another process called extrude curve. You can add it to the curve. Now, earlier I had mentioned about the importance of vectors. So extrude curves asks for a direction in which the curve needs to be extruded. So if you have let's say, vector along x-axis, vector along. You'll see how it changes.
Try refreshing.
Oh, yes.
Is the extrusion too small?
Extrusion,
No, maybe
I think
it's
it's vector.
in vector X. It doesn't know how to extrude it. Or no, something
Yeah,
wrong.
yeah. I think it's just x and y.
No, but
Let's
there is
try reset.
obviously
Yes, again.
a bug.
Another interesting function is that if you, this is not there in Grasshopper, I've noticed, you can click on the geometry and it takes you to the component, which is quite cool. So you don't get lost in the script. So that's about extruding of curves, simple surfaces. We've done simple surfaces. We could also look at solids. There are solid options where you could bring spheres, boxes inside these. Just a bit. About the sphere. So as you can see, there's quite a lot of options for creating geometry. We'll go into more transformations later on, as we discussed earlier. So we looked at some of these simple geometries. Now we'll try moving, scaling, mirroring these kind of functions. So this would require a bit more complexities involved. So let's try moving this sphere to the side. The easy way, you can double click and click on move. It asks for the geometry, provide it to the sphere, and it has a vector input. Now we can give which direction it needs to be moved. Let's move it in Z direction, and then a factor of 10. So just to exaggerate a bit, we can provide say 30. Right? And it creates both because it's both part of the script and you can access either at any time you want. But if you don't want it, you can hide it. Now we have moved the geometry. Now I would create a range input here just to get a better control over the. So this is The move commands, there are more transformative tools, so you can move, mirror, I would say rotate. Rotate is something else that would come handy. Let's take this rectangle. So the way you navigate is you can keep moving your nodes, keep it closer so that it's easier for you to kind of connect and progress with the script. So I'm using this geometry, the side raster geometry. Focus on this rectangle. Adding geometry, you have input for its center. So this is for the axis. Now it's taking origin as a center point. We could give angles. Currently, the angles are in radians. I'm sure most of us are familiar with degrees. So what you can do is if you go to math, under tools, you have degrees to radians. So you bring that here and give, let's say, 40 degrees. So it gets rotated along this axis. As you keep moving, it keeps changing. That's something you can do with rotate. Change the geometry and see how all that works. Probably give a range output so that you can visualize it better. Yeah, learning, what was that shortcut for the range one that you mentioned earlier?
Well, you can type the number, or you can even give it a range like 0 less 10 or 0 less 5 less 10, for example.
Yeah. So that way you can.
By the way, for disconnecting, you don't have to hold command and drag all the way. You can just click command or control in your case and click on the port, hold command.
Okay.
It will disconnect all if you have multiple.
Okay. Okay. That's pretty good. $360. See. Cool. So that's rotation. You have move. The other transformation tools like mirror, scaling. Scaling is also quite important. We can try scaling the same box object. Geometry. Yep. So that's also sorted. So scaling, These are some of the quick transformation things that you all can try out. Learning. Let's take a quick 5-minute break,
Mhm.
and then we can resume with the other things. What do you think?
Yeah.
Yeah.
With that.
Okay.
While
All
you
right,
go
guys.
in a break, I can answer some questions if there are
Okay.
any.
All right. All right. Cool.
I published a poll. While we have a break, can you guys take a minute to go to the polls? I don't know how it appears in front of you, but maybe if you could vote, we could understand better who has what kind of experience. We should have probably done that in the beginning to understand like how much time we should have dedicated to like the early things. There's so far one vote for no experience and one vote for very little, 2 votes for some, 3 votes for intermediate. Okay, some 1 vote for pro. Probably the pro and advanced guys. It's very boring for you, unless Safiz and Divya, it were you.
I think we should go through this, taking into consideration that most people, it's new for them.
Okay.
I think the one that Divya would be taking is slowly pushing it up a little bit, because otherwise it'll be challenging for them to understand the next workshops and the commands, directives. Yeah, there is a question relating to
So there's a question related to plotting, mathematical plotting of surfaces, by Hector. So he's asking if we can use equations to plot mathematical parametric surfaces on Beegraphy.
I'm not sure
so
I understood the questions, but there is math expression. Is it something that the question is about? Unless you guys understood it better, maybe you can answer. Okay,
You share the link.
the link. Let's see. So input an equation for like a surface.
I don't think it is there yet, but we can use multiple equations like multiple math operators to create this surface. So I think most minimal surface is doable, but you cannot do it directly by putting the equations there, but you will have to rather use the sine cos operator or other mathematical operators that are there, and then combine them to create these kind of surfaces. So it's it's possible to create the surface, but not by directly putting the equation.
So if you put directly the equation, can you see my screen?
Yes, you are able to see the screen.
So if you can add ports here, like for multiple variables, you can't rename them at the moment. You can change parameters, like values here, or put like variables here.
Yeah.
And the right versions. How do you square root? Square root. Yes, you can do the equations, but then how you apply those values, it's a different question. Depends on your approach. So create points and use those values, I don't know, for those points, for example. And then construct lines and loft them, curves, loft the curves. That's how you can probably do that in Beegraphy, but like create a surface and just use like a math expression as an input. To give everyone on this call some understanding, I'm not myself a computational designer. I just know how to use the tool, but I'm not a master. I clicked some in the poll myself. But if you guys can share how you do it in Grasshopper, then maybe we can explore a bit and find a way how to do the same in Beegraphy or add a node for that. Is there a way, by the way, to do that, Safis?
Yes, in Grasshopper we can do that.
Yeah.
What's the name of the node?
It's not node, but it is a mathematical expression which we have to input. So here also we can do that in Beegraphy also, but we will have to use multiple operators actually to do that.
Yeah, maybe after the call you could educate me a bit, share some links.
I can explain it after the call. Okay, next question was how to simplify, reverse, flatten, and graft in Beegraphy. I think anyone of you would like to take this one?
Are you guys gonna be showing that?
Yeah.
In this,
Simplify, reverse, flatten, and graft.
like the short answer that there are a group of nodes for operating or managing data trees. But if you guys are gonna be showing it in this workshop, maybe or the short answer, you just double click,
I think
type simplify, reverse,
Yeah.
flatten, graft.
I think we'll just explain very simply what they actually perform and why it is required, and then we'll go to understanding how data flows in the script. So I think we'll touch base on that.
Mhm.
Okay, the short answer is it's possible. I mean, it is doable in Beegraphy, and we will show you later how to do that. Okay, the next question is learning to you. Is there any scope for AI in the future?
Yes, most definitely. In the future, it's just the matter of when. No, well, they didn't ask when, but probably not this year.
Okay.
The easiest things that we can do early is use AI for rendering, for creative renders. That we may do earlier, but the more complex things that put in a prompt that will create a an algorithm, like an entire script, that's something for the next year.
Thank you.
Quickly get back to
Yeah.
the last few bits. So what we need to do now is some transformation techniques like Boolean, quick Boolean paneling would be interesting to add panels to certain surfaces, how that can be added, and then adding material and also exporting into the format of exporting. So we'll quickly show that and then move to the next stage. Right, so if you have to, I'm sure most of you guys would know what Boolean is. It's like combining solids and also subtracting solids from each other. So we can try to do one Boolean, and then we'll try to do a paneling on a surface, and then we'll try to provide material to these two, and then end this session too, and then head to the third one. So we have a geometry here that we have scaled. Now what we'll do is we'll try to bring a sphere. Control the radius to 5. So now you see the geometry is overlapping. So what we'll try to do is we'll try to do one Boolean union, combine this geometry together, and then subtract it as well. We have these two. Now we have the Boolean tools all under here. So you have Boolean operations. You have Boolean surface union. You have solid union. So let's bring that. Again, hold shift to bring the other. Right. And if you hide both of them, now it's working. So that's one solid union. And if you want to find difference of it, you can do a Boolean difference. Same process. So you provide the initial solid that you want to keep, and then you take the other one that you want to cut from. Hide the others.
You have something visible. Can you click on that sphere in the middle? Yep.
Yeah. So now we have a Boolean difference. So you have these subtract functions as well that you can incorporate into your form exploration. Next thing would be paneling. Paneling is it's interesting. So let's hide what we've done so far. I have all the panels here. Pick up a simple one. Surface, add the surface, divide. You can, same thing, add a range input to it. and you can start creating different types of panels. And then you can access the panels here and also the centers here separately. So that's mostly about how you can create these panels. Another thing that I will show quickly is adding material to this. So you have the materials tab in a texture. So this is applying material. I think it would be better to apply it on that geometry that we created earlier. Geometries.
It wants a color because of the color input. It shows an error.
Yeah, you can pick it from any part of the screen and then add it to the color. You can provide material. You can also adjust metallicity and roughness. I'm going to add a quick slider on this. And to see the material more clearly, just change the render style. Yeah, and once you're kind of happy with your model or geometry, what you can add is you can add an exporter in whichever format you prefer. Bring your exporter, connect it to the geometry. And then when you go here, you have an option to export. So this is where you can, if you have multiple exporters, you'll get those options here. You have STL, you have STP, OBJ, TXF, any format, wherever you want to take this. It'll show up here when you export. You can also give the polygon count if you want to process a much detailed model. That's also an option. And then when you download, you can then take it further and develop it. Yeah, that's mostly about some of the basics of Beegraphy in this part 2. We'll do slightly more components and detailed versions in the next module, which Divya would be looking into. And then we'll slowly up the game as we move from workshop to workshop. Yeah, if you guys have any questions.
Sefis, I just thought that maybe quickly go over the configurator mode and the demo mode.
Oh, yes. So if we go into the configurator mode, we can view the model with all the variables that we had added earlier. So currently what we made active are those metallicity and the color options. So learning, we'll cover this in the next module as well. And then we can come back to it and show it in more detail. So just this module, we'll just keep it a bit rough.
Okay.
And then we'll add this. Yeah. So if people have any questions about like just the basics of these steps, I'm sure it's there in other tools as well. But like for people who are new to get introduction to this is quite important. Yeah, if you guys have any questions, please drop in the chat. We'll take like another 10 minutes break, and then I think that we could start with the first module related to the categories.
Size of the panel in the paneling tool. Oh, let me try. I don't think it's possible similar to Grasshopper. but-
Currently, it's more on the U and V values based on the subdivision.
No, I think he's talking about the debug panel, like resizing the debug panel. Let me. No, I just tried. It's not possible. Adding nodes to groups. Yeah, you can create groups and then add nodes to groups in a similar manner, like in Grasshopper. Okay, Safiz is now gonna show that. So he selected a group, and then there's a folder type icon on top.
You can create a group. You can remove, ungroup it. You can also align a group of things. These
And
things will definitely tidy up your script.
and you also can click Control G or Command G for those who use Mac to create a group, and then you can also rename the nodes, the inputs, and the groups by double clicking on the name. And when something is grouped, it will be also displayed as grouped in the demo mode and configurator mode. So you can click on the group 01 and it will expand. And you can rename those inputs so that it's clear for everyone who's
Yeah,
open, like those range inputs for.
yeah, these ones, no? Okay. Currently, we haven't given, so we could.
Scott, I don't know how to answer the question. Like, is your question why we decided to do it in the web, or in general? Like, if the question is about graphical programming interface, it's not us who invented it. The most popular tool for that is Grasshopper, the industry standard, which is a really great tool, very powerful. So our approach was to do the same, but in the web, so that more people have access to it, so that it's easy to integrate, so that people can collaborate in real time and stop sending each other files or even sharing static files instead of letting their collaborators participate in the design process. Like, for example, as Safis is now doing in the configurator or demo mode, when a person who doesn't know visual programming or computer aided design, you can participate in the process and adjust the model just with the intuitive interface, like with sliders or drop downs. I see. Well, hopefully we can make a good tool that you can use with your clients.
think
Questions, I think we've covered most of the
Did I miss
questions.
anything? I think. Oh, yeah, there was a question. Any plans to add loop function where next input is based on the last output? Yes, definitely we will. It's on our task board. It's just we didn't get time to develop it further. So thanks for another reminder that something that you want. Oh, just noticed that you were talking about the panel size on a surface. Yeah. Shafi's
Yeah,
answered.
yeah. All right. But let's head to the third part of the module then.
Yeah, go ahead.
Should I start?
Yep. Let's go.
Hi everyone, I'm Divya. I'll be taking on for the third part, which is related to one of the categories of the competition. It's called art and collectibles. So I'll just share my screen. Is it visible to everyone? Is it visible to everyone?
Yes.
Yes, it is.
Okay. So I'll just take you through a brief presentation. We'll try to make it very compact and concise and quick. So art and collectible with Beegraphy, the main the intent of this particular section is we'll try to understand the workshop's own intent, and then existing references will be shown about what all can be produced through such a software, and then building on the design that we have in mind and how the logic is built for it to be translated parametrically into a form. Then we'll start exploring the design on Beegraphy, and then we'll try to add some materials. We'll explore configurator mode and collaboration space, and then we'll also explore how to export such a geometry for 3D printing or other purposes. And then we'll go to the challenge itself. So the intent of this particular category of the competition is to generate something which is an intersection of art and technology. So it should be a unique art piece or something should be generative. It can be generative art. It can be 3D printed sculptures, interactive installations, anything that is collectible and can be produced through such a tool as Beegraphy. And then if we can push the artistic expression further through such a tool. So it can be used as well for mere sculptures or awards or any of decors. So that is the intent. And then some examples which are readily available for our reference. Yeah, and it can be smaller forms, it can be tall sculptures. And what we kind of observe in all of these is that we have a very repetitive module or some kind of a element that we can modify, but at the same time, as it repeats itself, it also customizes itself, so it is variable as it as it replicates itself throughout the geometry. So there are multiple ways, and these are multiple examples of how that process can be achieved. Go forward. So what we today will try to achieve is one of the sculptures by Herschel Shapiro. He does a lot of his works in 3D printing, and he generates these really elegant forms, quite with the use of different 3D printing filaments, or sometimes spray painting over basic 3D printing elements, and then you have an assembly that you can devise yourself. How do you want to assemble them together? What should be the connection details, and how to go about it? So what we today will try to achieve is a form like this, and we will just try to understand how to build a logic for such a form, and then this particular logic can then be applied to any one of these forms as well as this. So I think we can go forward to the Beegraphy page. Is my Beegraphy page visible for everyone?
Yes, yes.
Yeah. So if everyone wants to start along, we can start at this page. I hope everyone has logged in and have this page, the editor page, on their systems. So the first thing we can do is create a new model, and you can type in the model, and the model will come in this space here. We can also left click on this, and then we can see there are multiple options, but for collaborating on with other editors, we can share this, and then we can tweak some settings here to see to give access to multiple people, and editor or viewer or configurator, and then we can just copy link and share it with people we want to collaborate with. So for the current workshop, I've already created a model. It's called Art and Collectibles, and we'll try to make the geometry in it. So maybe everyone can follow the suit, and we are in this space now. So I'll just try to build a logic. I'll just try to take us to a logic of the parametric building. Can everyone see the whiteboard space? Yeah. Yeah. Okay. So as we saw, if we want to develop something like this, then what should be our building block for this? So it's a hexagon panel grid, and then you have these interesting shapes that come out of that base, and these are constructed using simple curves. So for creating something like this, the first thing we might require is generating a hexagonal grid. So each of these modules is basically a hexagon, which is extruded in the Z direction. So this is our base. And then you have a geometry which is a slightly eccentric geometry. So it rotates around, and it takes a interesting shape. And we would try to get this generate the shape in Beegraphy. So if we want to start, we would require a hexagonal grid first. Then we would require okay, we'll come to that part in a bit. So let's start with the hexagonal grid first. So if I go into the Beegraphy space, I can just write hexagon, and you'll have two options. The first is hexagonal grid. The second one is hexagonal panel. The one we'll go with is the hexagonal grid. So when I put the component here, you can see it has already zoomed in the modeling space, and we already have a grid in place. You can understand there are some inputs and there are two outputs. The input it is asking is the origin, the radius of the hexagons, X and Y, and padding. Padding is basically spacing between the hexagons. So origin by default is the 0, 0, and we can see it has started the grid from the 0, 0 point on the modeling space, and it has gone in the our x direction is the red one here and y is that one. So it has gone in the x and y direction. So we can give it a, the first thing we can do is we can give it a radius. So radius is basically the radius of each, the size of each of the hexagons. So if I have to make this a constructible model, like a buildable model, then I think I'll go with a radius of 100, which would make these individual hexagons a 200 millimeter wide base. So I'll use that and put that in radius. So you can see the grid has scaled up. Then the next thing we'll do is increase the x and y count. So I think I'll increase this to 15. I'll try to keep this constant for both for the ease of the process. And we can see we have an array of points already. The next thing we can do is increase or decrease the spacing in between. I think it's 5. Sorry, it's 10. We can go with a 5. Yeah. Okay. Here I'll redo the constants because I want these to be variables. These are currently constants, and I want this to be available in the configurator mode. So I'll just type in 100 again, and I'll go for the range input. And I'll change its name here to hexagon size. Same thing I'll do for the other one, 15, range input. And I'll change its name by double clicking on it to the grid hexagon grid size. And then I'll drag and copy it. And I'll change the last one, which was 5 here. I'll change this to 5 as well. And I'll change the name to the grid spacing. So we have 3 ranges now. And I'll replace these with the range. So this goes here, this goes in X and Y, and this goes in our spacing. Yeah. So now we have a grid. Now what if I go back to that particular design, we can see it has a hexagonal shape to it, and it's not a squarish shape. But what we can try is maybe making a circular shape for the whole assembly together. So for that, what I'll try to do is make a circle first. So I'll double click on the space, I'll write circle. And it is asking for an origin point and a radius. I can just stay with the basic and I can go, the radius I can take as, I can make it 1 meter wide in totality. So I can go with 500, which is 500 millimeters. And I'll give that as the radius. So you can see the circle has come there. It's a bit small. Maybe we can reduce down on the radius of the hexagons. We can make it 50. Yeah, that looks a better size. So it's each of the hexagons now are like 10 centimeters wide. So we have the circle. Now what we would want to do is move the circle to somewhere in between the grid. So for that, again, I would just move the circle. So I'll write move. I'll put the circle in geometry. And then I'll introduce. So I have to move the circle first in the X direction and then the Y direction. So I'll just move in first the X direction. So vector X. And then I can give the vector X some amplitude, which is the factor here. And this amplitude can be, our circle size was around 500. So we can give it 1,000, or sorry, a 525, so that it's slightly beyond. So you can see the circle has been moved, but the previous circle is also visible. So we can just preview of that particular circle. Now the circle is here, but we would want it to be in the middle of the grid. So we can just use, we can just move our already moved circle in the x direction in the y direction. So I'll just write y here and then input the same amplitude that I gave there. So now I'll just preview of this whole thing, and we can see the circle is somewhere in the middle of the grid. And now we have some hexagons which are outside the circle and some hexagons which are inside the circle. So the next logical step for something like this would be that we analyze which of these hexagons are inside the circle and which of these hexagons are outside the circle. So for doing something like that, I'll just increase this a bit more. I think I'll go for 550. So we'll push the circle a bit more inside. And then I'll do a simple analysis. All our analysis parameters are also present in this particular tool set. So if you go into tools, you can see there is a particular section dedicated to curve analysis. And in this, there is a particular tool called point and curve. And what point and curve does is it tells us whether a point is inside a particular curve or it is outside. It just gives us a Boolean answer, whether it is true or it is false. Actually, it gives us three outputs. It gives 0 if it is inside, if it gives 1 if it is on the curve, and it gives 2 if it is outside the curve. So there are 3 particular outputs. So for testing each of these hexagons, we have the circle with us. Circle would be our curve for testing out the points. The point input that you see here is basically the points we are already getting from the hexagonal grid. So I'll just use them for the analysis, and I'll plug this into the component. Now we have an output. If you click on number, here, you can see it is giving us a lot of values. Those are in zeros, twos, and ones only, and you can understand what it means by those values, those outputs which it is telling us. So what we want is it should be inside, which is 2 in this case. So we just want to segregate those hexagons from the rest of the grid. So for that, I'll use another interesting component Beegraphy has. It's called dispatch. Dispatch can be used to segregate a set of values based on a number, based on a analysis parameter. So what we'll first do is so this says that if the output is 2, then it is inside. So we want to just check for all these numbers if they are larger than or lesser than 2. So I'll just write a constant here. I'll just write 1, and I'll plug this in to this. So if you click on the output, you can see it is giving us a true and false answer, whether it is inside or it is outside. So in the dispatch list, it uses that particular output of true and false to tell us if that hexagon is falling in the circle or not. So I'll put this in, and the list we want to segregate is the hexagons output. So I'll plug this in here. So as you can see, it is giving us 2 lists now, one which is inside and one which is outside. If I just want to see one of the lists, I can click on the other one and just preview of one of the lists. I can also preview of the rest of the model. So as you can see, we have segregated the hexagons which were falling out of the circle. So this provides us a nice base for us to start modeling the rest of the geometry. Any questions till now? Should I speed down or? Okay.
Person says a little bit, maybe.
Yeah, I'll just speed down a bit. Okay, so I'll just recap a bit. First, we made a hexagonal grid. Then we made a circle, which we utilized to only get uh, a circular base, a circular assembly base, and then we use that circular base to segregate the hexagons we want to use to make that geometry. So so this is the last part of the process. So now we have all the hexagons we want to use for making the geometry. The first thing, I'll go back to the whiteboard again. So for making such a geometry on the top, um, which is a curving surface and it changes its cross section across, we can use something called loft. So now what loft does is you provide it curves. So say I provided it this particular curve, and then I'll provide it another curve which is slightly larger, and I'll provide it a smaller curve, and these are basically cross sections of that surface. And then I ask it to loft them. So what it will do is it will blend a surface between these particular sections, and then yeah, it will give us a surface through that parameter, through that process. So we'll use something like that. So if you want to create a geometry of this sorts, then we'll have a cross section for the base, we'll have a cross section for the middle part, and then we'll have a cross section for the top, and then we will just loft these together. So um, for making a cross section, we can just go with a basic circle. So we would have to generate a circle at each of the midpoints of the hexagonal panel. So I can make the base first, then I can make the middle circle, then I'll make the top circle, and then I would have to move them up in in their respective heights, and then I would have to loft a surface through them. So that is what I will try to attempt now. So I have the dispatch list. I want to create circle there. For creating a circle, I would first need a point for the circle to start from. So for that, we can use centroid. I will put the list we have isolated, and you can see it is only providing a centroids for that particular isolated list. Now these centroids we can use for creating circle. So I'll write circle, and I'll put the uh, put the centroid into the circle. And as we can see, we have really small circles. Maybe we can increase them in size, but they don't have to be larger than the hexagon itself. So I'll go for something in the range of 40. So this, I'll just change the name to lower circle radius, and I'll plug this in into radius. So as we can see, we have a circle for each of the hexagons. Now we want to develop circles for the middle cross section and the top cross section as well. So I will use the same centroid. So I'll push this back. I'll space it out a bit more. I will select these two options and I'll drag them down and press Alt so that they copy. So I have two sets now, and I can reduce down the radius by certain amounts. I guess I can go with 27. So that's, you can see there are two circles now which are concentric on the same center point. And then I can do again the same thing. I'll drag it down and press Alt to copy it, and then I'll reduce this down further to 7. So now we have 3 circles which are concentric. So now what we would want to do to make a surface out of this is we would want first these cross sections to raise to that height so that we can make a surface. So we'll start by moving the middle one first. So for moving a curve or any geometry, we use the move component. I'll plug the curve into the geometry, and you can see it has already moved the circles to a certain height, which is default, uh, which is 10 in this case. but we can give it a particular direction. So I'll give it a direction in the z vector. So I'll first write z. I'll plug the z vector into uh, the move. Then I will give it say 50. Again, this needs to be a range. So I'll write 50, go for the range input, and I can change the range input to middle circle height. Oh, I have not changed this to middle circle. So middle circle radius, and this would be upper circle radius. Okay, so now I'll connect this here, and then it has risen up to a height that we require, 50 in this case. We can always constrain that height. It is maximum 100 here. I can go for maximum 60, go for minimum 10. Yeah. So this has risen. We'll do the same thing again for the upper circle as well. So I can write the move component. Then I'll put in the geometry, which is the circle, and then I'll give it a z vector, and I will give it a height. In this case, I can make it 100. Again, range input, and I'll change the name to upper circle height. So now we have three circles. I'll push this here. Now we have three particular circles at different heights, which we want to make a surface from, right? And I'll just hide the rest of the model. So now if I go on to loft them, I'll select loft surface, and I'll plug one of the curves in. I can see there is an error already. It is making a surface, but it is joining all the circles together which are at the same level, same height level. So we'll try to understand how Beegraphy stores data. So if I open a panel for us to understand this, I'll plug the curve in, and I'll open this branch out. I can see that Beegraphy is storing all the circles which were on that level, the base level, in the 000 branch, which is, so if I think I'll use a whiteboard for. So any parametric software generally uses a branch system. So the data is stored in particular branches. These are, you can understand them as classrooms basically of a school. So if you are at the entrance of a school and you want to find someone who is sitting at in some particular classroom at some particular bench on that classroom, then you would want to if you want to tell the guard to get them, then you would have to tell exactly what bench they are sitting on in that classroom, what classroom it is, what floor it is, what building it is, and then what department it is, all of that. So that is how most parametric softwares would store data in the software. So any questions about this? I'll just try to explain it a bit more. So for instance, we have a lot of hexagons, and we can see the hexagons in this case. We have a lot of circles, and we can see all the circles are stored together, but they are stored at the 000 level of the storage. If we go and see what the level was in the starting, then we can see the level was 00. So the data was stored at 00 level. And then as we move through the script, the data goes on storing at different levels so that it becomes easier for us to model the geometry. Now I go into circle and I see this is stored at 00 level. it tells me that all of this data is in the same classroom, and if I want to make a shape, all of the data will be used together to make that shape. But what if I want to isolate each of the data, isolate each of these data into separate sets for it to be utilized separately? Then we can use components such as grafting. So if I use a paneling tool again to make you understand. So here the curve was stored on 0, 0, 0 level, and you can see all of the individual circles that are stored here. And if we graph this list, we can see all of these individual curves are now being grafted up or stored at a higher level individually. They are no more together in a single set. So we can see it's now 0, 0, 0, which is like four levels up. This was 3 levels up, and all of them have an index which is 0, 1, 2, 3, goes up all the way up to 105. So grafting just basically uh, separates the set itself into multiple individual sets. And how this becomes useful for us is that if we are putting into a lofting component, then all of the data which is in a single set usually interacts together. So we don't want that. So that's why we'll use grafting for that. So I'll copy this thrice and I'll plug the geometry in. And you can see if I put this together, I can press shift and I can drag another wire to the lofting component. And you can see it has started developing surfaces based on the cross sections we gave. But this looks quite simple. It looks quite boring. It doesn't have any character. If we want to achieve something like this, we would have to give it a twisting motion, basically. So for doing that, if I go back to my sketch, you can see that the cross sections are not just moved in the x direction, they are also moved in the y and the z direction. Y and the x direction. So these cross sections are first move up and then they moved sideways, or they are rotated. So we can also rotate them based on a center point. Great. So again, any questions so far? I hope everyone is able to catch up. Okay. So we have the loft surfaces now. The next thing we would want to do it is give that twist. And we'll only do it for the middle section. So what we will do is we have all of these middle sections and we would just rotate the whole set together from the center point of the circle. So, and we would have to do this before we make the loft. So I'll just move this forward. We have these middle sections. We will use a component called rotate. And we'll plug this geometry in. Now, as soon as we plug this in, we can see that it has rotated all the set together, but it has rotated it around the grid center, which is somewhere here. So, but we want this to be rotated from the center point of the circle. So I can go back to where I made the circle itself, which was this, and I can use centroid to get the center point of the circle, which is here. Now I can move this component a bit ahead and I can use that as my center point for rotation. The second thing it is asking is angle. So if I click on angle, I can see it is saying rotation angle is in radians. So I would want it to be in degrees. So I can use the component called degree to radian, degree to deg to rad, and then I can put this in the angle and give it say 5 degrees. Again, I want this to be a range, so I'll just I'll write 5 and then I'll go for the range input, and I'll change this its name to rotation degree, and I'll plug this in to the rotation. Now now I have the circles rotated. You can observe they are slightly rotated. They are rotated from the center point. And now if
Divya,
I, yeah,
Is there? Yeah, the
screen
screen.
is gone.
You'll have to share again.
so sorry, share. Is it visible now?
Yes, it's
Uh-huh.
back.
Okay. So was I able to tell this part? The rotate.
Yes.
Yeah, yeah.
Okay. So we have rotated all of this set together from a center point. Now I just have to plug this in to the graph tree, and we can see the geometry update itself. It's a bit overcrowded, so I'll just select the rest of the part and I'll just press hide, even for the rest of it. So we can see we have a groove which is a bit eccentric. It's closer to what we had in mind earlier. And now but we can see this is a single surface. It is not a solid. It is empty from inside. So we can use the component called cap, and this will help us in closing all of these surfaces and converting it into a solid so that we can use it for 3D printing as well. So the upper part of the geometry is kind of done. We can always modify it. We can focus on the lower part, which is the base, which is the hexagon itself. If I go back to where we dispatched our list, this particular component, I can. So this was the, if I preview this on, we can see these were the hexagonal bases for each of these, and I can use that to make a surface. So I'll use curve to surface, and I'll plug my list into this component, and you can see it has already made a surface there. Now what we have to do is we have to extrude the surface down. So I'll use extrude, and I can go to extrude surface. I'll plug the surface in, and then we can see the surface is extruded, but it is extruded in the z direction, up in the positive z direction. So we'll give it a negative z direction. For that, I'll first introduce the z vector, and I'll plug that in. And then I'll give the z vector a factor. Currently it's 10. I'll just keep it with 10 only. But what I'll do, I'll give it an opposite or negative value. So the 10 will first go into opposite, which will make it a negative value, and then it will go into factor. So now we have the extrusion going in the other direction. So now we have the bases also ready for this geometry. Okay, so I'll make this also into a range. So I'll write 10 again. I'll put range input, and I'll change this to base height, and I'll put this in. Preview the rest of the model off. Great. So now we have the base as well as the upper geometry with us. I'll push this forward. Now maybe we can give it a material. So if I double click and write material here, we can apply a material. I'll put the bases here, and I can give it a color. So if I'll double click, write color, there is a color picker component, and I can just change the color to some other color. So for previewing that, we would have to hide the previous part. So maybe, yeah, we can see it as all a single color now. it's green. Maybe I can change it to something more whiter. Yeah. Great. So now we just go and do the same thing for the other part as well. I'll drag this and copy. We'll use this for our geometry above, and I can give it a different color, maybe red. Yeah. Move it a bit forward. Move these a bit forward. So if I preview of the whole of the previous part, you can see we have a geometry, it is twisting, and we can always play with the parameters that we use to configure it. So now we can probably try using the configurator mode for this. For that, we would first have to show all the ranges we have put in the model. So I'll just switch on all the range components I have. This one, this one, this one, this one. It's a good practice to give names to each of them so that we can understand what they do when we go into the configurator mode. I think we have all the ranges. And the color picker also, I'll just preview on so that we can change color there. Great. So now we can go on to the configurator mode. Will take its time. Yeah. I think I don't have the geometry. Okay, I'll just.
Can you refresh? I don't know what's wrong.
Yeah. I think I'll just use, or should I change the color?
No, I don't think the problem is with the color, but can you go to the demo mode instead of configurator? Just curious if the demo mode will work.
No, I think I'll just use it without the material for now. Yeah, maybe it's some material.
Yes, I think the problem is with the default values of the materials for roughness, metallicity, and opacity.
Yeah.
It returns an error. It doesn't like if you refresh. Actually, if you refresh the script,
This part? Okay.
yeah, refresh it. It will probably return.
Oh, I think it's still not coming. Like even without. It is showing here.
Can you
What if
refresh
I
this page?
Okay, I'll refresh this part. Should I just do refresh or go back?
Yeah, refresh the tab. No, just refresh the tab.
Okay. I'll just
Check.
delete the.
Yep.
Just a second.
Some wire is disconnected, or
Yeah, I was facing this thing before as well. I'll just extrude
What?
surface, graft. I'll just have to put this back here. I think the loft component was having some issue. Loft surface.
So the nodes suddenly disappear.
Yeah, I was having this issue. Might be related to something. Graph 3, list, merge. And so this is our first one. Second one. Third one. This goes into curves.
Missing
The
the
lower,
upper circle.
yeah. So yeah, for some reason the lower circle.
Can you refresh again?
7.
What's it? What is it outputting?
Yeah,
Attach a panel.
I think I'll just replace this thing circle with the radius. Change this here. Oh, I think the move part is missing. Sorry. Move part got missing. I'll just add this again. Change this to 100. Yeah, I think we have the circles now. Put this into draft. Yeah, we have the geometry. Just put this into this. Yeah, let's try configure it. Yeah, now it's coming. So since we gave the ranges, we can always change the ranges. I'll change the rotation. I think I switched it off. I'll go back to this thing. I'll preview this on. I'll go back to configurator. I think I would have to restart configurator.
Yeah, you could have just refreshed the tab.
Oh, okay, yeah, sorry. So I can change the rotation degree. It looks a bit less. Yeah, I just change the color. Sorry.
Maybe hide the centroids or the points.
Yeah. Centroids were coming from
The left somewhere.
it should be this one.
Yeah.
And then I'll also preview on these so that I can modify them here. Yeah. So now I can change the color something lighter so that we can see the geometry getting modified. I can change the rotation radius, rotation degree. So I can go for 10, which is my extreme in this case, extreme of the range, or we can make it 0, which will make it a simple geometry. We can also go back to the base one, and then we can increase the height or decrease the height of the circle. So I can just say 75. It can drastically change the geometry into something else. So we have tons of ways we can play with the geometry itself. We can increase the grid as well, or we can increase the size of the circle. So all of this we can always play with, and gives quite a lot of flexibility. We can share it with our clients, and they can play with what they want, and that can help us quite a lot in reaching solutions. So now that is how the configurator mode basically works. But what we can also try now is to export this geometry so that we can use it for 3D printing. So if I just moved it a bit further, and I have to export the geometry. I can use their export components, which are located here. These are STL, STP, OBJ, DXF, IGES. We can just go for STL or STP for the time. So if I double click and write STL, I can see there's an STL exporter. I can click on that and I can give it the geometry I want to export. I can also double click on the exporter and I can write, this is my, what was this? This is my base geometry. So I can write base export. And I can do the same thing for the other one as well. So I can put this geometry here. I can write top export. And these are my two exporters. And yeah, and then if I want to export the file, then I can go to the exporter tab here. Sorry, not this. I can go to the name of the file, and then if you click on that, you'll have that exporter thing, and then we can choose which one we want to export. So I want to export the base or the STL, or I want to export them together. If I want to export them together, I can merge the list together. So if I'll just use list merge. I can merge this. I can add another point, and I can make a new STL exporter. I can write it as unified export. Yeah. Now I can go again to the exporter and I can choose the unified export. I think it would be this one. And then I can just click download. It will take some time. Yeah, Lalit.
Yeah, I was just saying that maybe after refresh, the names would update.
Yeah. Yeah, so you can see it took some time because the geometry is a bit complex, but we have the geometry. You can view it in any of the viewers. I think you can view it in Rhino as well. In Mac, for some instance, it can be viewed in preview as well. Or you can take it directly to a 3D printing slicing software. So you can take it directly to Cura. Cura Ultimaker. I don't think that is available for Mac, but you can directly take it to Cura, and we can directly print this right away after scaling it down on Cura and slicing it. So, I mean, we understood how the logic is built, how we start, and then we have ways we can use collaboration, and we have ways where we can export the geometry as well once it is decided and sent to 3D printing. So any questions anyone has? Should I can understand it might have been a bit a steep. Can you please explain the dispatch list part? Yeah, sure. Let me share again. Is my screen visible? Yeah.
Yes.
So I'll go back to the dispatch part, which was this, and this is an amazing component to use because it gives you too much power, like to choose a particular set out of a particular set, out of a condition. So in dispatch list, the set we were giving it was the grid of hexagons, all of this, but we only wanted a part of it and not the whole thing for our thing. So what dispatch would do, it is a very simple component. It just takes a list. So we give it all the list and we give it a true and false value. And what did the true and false value actually did was it just told the dispatch component whether that particular hexagon, for that particular hexagon, whether it is true or false that it is inside or outside the circle. So, and how do we get that true and false? So for that, we had to use the point and curve analysis component. This particular component only analyzes something for you. So what we wanted to analyze was whether the points, the centroids of the hexagons are inside the curve or not. So for that, it required an input of curve. The curve was our circle, and it required all the points we wanted to analyze. So we gave it the circle and we gave it the points, and the output it gave was this numbers. So if you click on the numbers, you can see it was telling us the relationship between the curve and the point. So if the point was falling outside, it was giving out an output of 0. If it was on the curve, it was giving 1, and if it was inside the curve, it was giving 2. So it is very specific into what analysis it is giving you. So once we have these numbers, the only one we are concerned with is the one which is inside the curve. So the one which is inside the curve is 2. The output is always 2 for them. So what we wanted to isolate, or we wanted to make a true or false based on this particular thing. That if the output is 2, then we will then it should be true that it is outside. If it is 0 or 1, it will be false. So what we did was we just used the larger than component larger than 1 to segregate only those hexagons which had an output of 2, or which means it is inside the curve, and that we put in the dispatch component. So that gave us all of those which were inside. There were other questions as well. I think dispatch, which function was used to select curves within. So it was point and curve.
The other one is if we can use panel on curved surface,
Like
like
a
a cylinder.
using those hexagonal
Yeah.
panels. Yeah, I think you can do that. We can try, but one thing is there that when we apply a paneling tool on a surface, what Beegraphy does is it has trimmed surfaces and it's untrimmed surfaces. So trimmed surfaces are surfaces um, which have a boundary, but they are part of a larger surface. So they are cropped to that boundary, but they are actually part of a larger surface. And paneling tool will be applied to the larger surface and not the boundary itself. So for that, we would require a untrimmed surface, basically. So if
I think for the loft one, that could work, no? So
loft, yeah, maybe loft can work. I've not tried it here. It can work probably, yes.
yeah, for the loft.
Yeah, it
So,
just has to be a untrimmed surface.
so probably for each of those elements, you could apply another panel, and it might get more and more complicated the more. But I think that's what he's probably looking into.
Yeah. Can you repeat the rotation of the middle circles part? And from where did you extract the centroid? So the centroid was extracted. If you remember, we used the circle to isolate these particular panels. So I just use that circle to get the centroid. So for getting a centroid, you just have to use the component called centroid, and you can give it a geometry, a curve. And then it can just give you the center point of that geometry. So it came somewhere in the middle, and I use that as my base point for rotation. At first I was trying to okay, any more questions?
There was just one comment. I just replied for
Yeah.
a device with a touchpad, like on a phone or a tablet, connecting might be not intuitive, but
Yeah.
we're thinking of a way to enable that. Like you click on a port, then you click connect, and then select the other port that you want to connect to. But it's
Yeah.
something that we're yet to implement.
I'll just also say, so each of the shapes that I was talking about in the presentation, share my screen again. If I go to the presentation again and the shapes that we were discussing before, so each of these shapes can um, then be logically divided and then logically tackled and how to achieve such a shape. So in this particular case, you can understand that this is a lofted surface. So you can make this kind of a surface by making curves. So we can have a bottom curve, we can have a middle curve, we can have somewhere here, we can have a top one, we can have upper one, which is not planar, but it's at a different angle. We can do all of this using the curve editor tool in Beegraphy. And then what we can do is we can tween between the curves, or we can use or we can divide the curves into multiple points, and then we can make a curve between those curves, or through those points, to get a geometry like this. And similar logics we can always use for all the other kind of art and collectible objects. So this one is again based on a repetitive thing that is rotated at this particular point. So you have a cross section here, you have a cross section here, you have a cross section here, and this part is rotated around. Same thing we can achieve with this. Yeah, these can be a bit advanced, but like this is again very similar to what we were doing. And we can always use the image uh, image um,
Image
image
sampler.
image sampler tool for generating something like that. So each of these shapes can be broken down into logic based steps, and once we have those steps, then we can clearly define how we are going to modify these forms or generate these forms. Yeah.
There's one question about the trees. If we can show probably the script and the branches, is that the question? To just see the whole script again.
um
From no, yes.
okay. Right, by the random colors assigned to geometries. I think there's one question where just please, I think learning you can.
Yeah, regarding the colors. So we thought it's easier to differentiate items when they have different colors. So unless intentionally the designer wants to select a specific color, he wants to know when those items are different items or same items. So if it's different items, then we decided that colored items would be more intuitive. Maybe we're wrong. Maybe you give us feedback and tell us that it wasn't a good idea.
Um,
There was one more question which is related to the loop.
trees, right? Thing for the trees. Should I explain the theory of it, or should I explain the graph flattening and all of that? Should I?
I think earlier he mentioned so I think Nuno asked the question. Yeah, Nuno lost a few parts.
Yeah.
I don't know how we do this. Maybe it's connected to the another question. Is there a way to export high-res image of the script?
What do you mean by that? Like the script
Is
as
it
an
like the
image?
screen? Yeah, as an image.
Oh, no, didn't expect that. Is it something that people would do in Grasshopper? That's where the question is coming from.
Yeah. I think you can.
Yeah,
Okay, I'll put
I
it down.
think
Feature request.
that's something we could be added.
Export. Thanks a lot for that comment. Probably we can export as a PNG or JPEG. Some question. Can you answer the last question? Because I have the same question.
I think most of the softwares are based on mathematical calculus engines, calculus and physics engines. So I think they work with radians better than degrees, most of them. But I am also a bit guessing in that.
Uh, in fact, it would be quite easy to add or convert,
Degrees.
make default degrees. And if someone wants in radians, probably most people use degrees normally.
Well, any other questions, guys? Uh, I think we'll also be sharing the recordings, right? So maybe you can follow the script a bit more if you have any doubts in the recordings.
There was one question, I think, which is related to the loop function.
Loop.
I think I answered that one. It was like, can you use loops?
Yeah.
So
Yeah, I maybe, well,
very soon.
uh,
That's
I
what we
think
said.
we will add it soon. It's not possible at the moment.
Yeah. Learning about the Discord channel.
Oh, by the way, shall we share the link to Discord in the chat box for those who are not there yet? Or actually, Abhishek, did you shared the link, right?
Yeah, I shared the Discord link. We can share it again over here. It's right at the top.
Yeah, we did it twice. Okay. Oh, so there was a question about Discord. Okay, I didn't see that question. So now. So the recording of the script will be embedded into the Uni XYZ platform. So you can go to the Uni XYZ to the learning materials section. We will publish it there.
It will be shared by tomorrow.
Okay.
I think we have exceeded the time, but I'm sure everyone got some great insight to the tool. Okay, I think we can also set up some feedback links probably in the coming days so that we can keep working on for the upcoming sessions. I think that could be helpful for all of you. Just to wrap it up, thanks a lot. Thanks a lot, everyone, for joining the workshop session. This is the first workshop session. Then we'll have more coming up that relates to the other categories. If we have missed out on some tips and tricks, we'll also introduce that in the first part of the next workshop as well, so that we make sure that we don't miss out on these things that would help you have a better chance at the competition. So yeah, thanks a lot, Lernik, Divya, Abhishek, for joining. Amazing stuff, and everyone who joined for the workshop. Thanks a lot for the questions. Yep, it's been a fun time.
I also would like to add a couple of notes. So we shared the Discord link. Please join the Discord. If you have any questions after the session, you can post them on Discord. We will take every comment and question and feature request and bug report into consideration and try to fix everything, help you guys out. And if you have any requests for the workshops, you can also share that. We will take that into consideration for the further workshops. We have 3 more at least with coding, and probably there will be more by some of the jurors who are on the jury panel. And if you also have any ideas for the workshops, please, you can share. Feel free to share. We'll try maybe even engage some of, or do the content you want, or engage the people you want to hear, listen.
And 5th of August is the deadline, so don't forget to submit your entries over there for the first category of this competition.
Yeah, exactly.
And we have 3 more workshops coming in the month of August, September, and October, I believe. So you can check the schedule on the competition page, which I'll share the link in the chat box. So don't forget to be there in those workshops as well.
Mhm. Yeah, thanks for sharing the link. How get recording sessions in Discord? No. The recording.
Recording will be available on the competition page itself. So you will find a section on the left-hand side along with the category 1, 2, 3. There will be a section called Learning Resources, and we will be posting all the recorded sessions over there. So this will be uploaded by tomorrow, and you can find it over there.
All right, sounds good.
Okay.
Cool. Thanks a lot, everyone. Bye bye.
Thanks. Thank you all. Bye-bye.
All right.